Hello and welcome to lesson 5.3. Today what we're going to learn about is parallel and perpendicular lines. Parallel, perpendicular. Just to get started, we're going to review what parallel lines mean and what perpendicular lines mean. So when we're talking about parallel lines are two lines that would look like this. If you were to have those two lines side by side, they would never cross each other. They're going at the exact same rate. You probably had teacher in the past when you were in elementary school or middle school, they would put their arms side by side and they'd say that's parallel, right? They're running at the same rate. Mathematically, what that actually means is that those two lines have the same slope. So if you were to look at these, they have the same slope. Perfect. Perpendicular lines. When it comes to talking about perpendicular lines, we're actually talking about the opposite of the same slope, the opposite of parallel. So if you had one line like this, perpendicular would mean it's going the complete opposite direction like that. And when you have perpendicular lines, what you end up creating is a 90-degree angle in there, like that. Mathematically, the terminology we use for perpendicular lines is that the slopes are negative reciprocals. So a negative reciprocal means if you had a slope of, say, 2 over 3, the negative reciprocal means you change it to become negative. Reciprocal means you flip the fraction upside down. That means negative reciprocal. Wonderful. Mathematically, there's some other things that you could say in there. You could say if you multiplied the two slopes together, they equal -1. I just like to show it as negative reciprocal. I think that's the easiest way to do it. Let's try some questions. So class example 1. Consider the line segment AC. So that means you have a line from A to C. Okay. Line segment AC with a slope of 3 over 4. Just a reminder, that means 3 over 4 equals the rise over the run, right? That means it's rising 3 and then running 4 on your slope. Part A, write the slope of line segment GH, which is parallel to AC. Parallel means same slope. So if we wanted to have the same slope, that means the slope of GH, remember we represent the slope with the letter M, so that slope of GH would have to equal the exact same as the slope of AC, which is 3 over 4. Wonderful. Now, you don't have to write 3 over 4, so there's other ways you could do it. Right? We could represent this slope as a decimal, which we've talked about, so 0.75 would be the same thing. Or we could represent it as a different type of fraction, an equivalent fraction. So instead of 3 over 4, we could do 6 over 8. Right? So if I multiplied the top by 2 and the bottom by 2, it would give me an equivalent fraction of 6 over 8. Those are all the right answer, right? Because they all equal 3 over 4. So they're all the same fraction as the original slope, AC. Part B, write the slope of line segment BF, which is perpendicular. Perpendicular means negative reciprocal. So if I want my new slope of BF, M means slope, so slope of BF, to be perpendicular to AC, that means I need to take the slope 3 over 4 and turn it into its negative reciprocal. Negative means instead of being positive, it will now be negative. Reciprocal means you flip the fraction upside down. That is the negative reciprocal. That means my slope of BF must be negative 4 over 3. If you put that in your calculator, that's negative 1.3 repeated. Same answers. That would be perpendicular to AC because the slope is the negative reciprocal. Cool. We're going to get given some slopes here in class example 2, and we're going to decide if they're perpendicular, parallel, or neither. So the slopes of two lines are given. Determine if the lines are parallel, perpendicular, or neither. Question 1. This reads the slope of number 1 equals 1 over 4. This reads the slope of number 2 equals 3 over 12. At first glance, they do not look like they're the same slope, so they're not parallel, because parallel would mean same slope. Second check would be, are they perpendicular? Perpendicular would be the negative reciprocal. I know this isn't the negative reciprocal because 1 over 4 would turn into negative 4 over 1. So my initial thought is that it's neither. However, what I didn't consider was that these two fractions might actually be the same. They might be equivalent or equal. The best way to check if they're equal is to just either calculate them as a decimal or write them in lowest terms. If we were to change both of these into decimals, 1 over 4 in your calculator, so 1 divided by 4, is 0.25. 3 over 12 in your calculator is also 0.25. This means the slopes actually are the same. So the fractions didn't look the same, but they were equal. They were equivalent fractions. So these are the same, so we do have parallel lines. It's very important when you're talking about parallel and perpendicular lines that you convert things in the lowest terms or you convert things into decimals. That way you can really tell if things are perpendicular, parallel, or neither. Awesome. B. If we look at B, first thing I'm going to check is, are they parallel? They don't look like they're the same. If we were to put them in our calculator, 5 over 7, so the first slope, if you put 5 over 7 into your calculator, you get 0.71, and a bunch of other numbers. If you put 14 over 10 in your calculator, you get 1.4. Those are not parallel. Therefore, they are not the same. My next thing I want to check is, are they perpendicular? To be perpendicular means one of them must be the negative reciprocal of the other one. So what I'm going to do is I'm going to figure out what's perpendicular to 0.71 or what's perpendicular to 5 over 7. To make that perpendicular, I need to make it negative and then flip the fraction. This is perpendicular to this. If I was to put that in my calculator, negative 7 over 5 equals negative 1.4, which if we check is very close to our second slope. The difference is my negative reciprocal should have become negative. This one is not negative. So these are not perpendicular. The number ended up being the same, but the negative sign is missing. So these are not perpendicular. They are not parallel. These two slopes are neither. Cool. If you want, you could pause right now and then go do some of the practice questions below. So you go do questions 1 to 6 if you want. If you want to just wait, you can do that too. All right. Class example 3. It says, if P is the point 4, 7 and Q is the point 6, negative 2, find the slope of a line segment that is parallel to PQ. Parallel would mean same slope. So we want the same slope as P to Q. However, we don't know what the slope PQ is. So we actually have to calculate it. From previous lessons, we learned that to do slope, when you have 2 points given to you, you're going to use the formula y1 minus y2 divided by x1 minus x2. That represents rise over run. Looking at our points, I'm going to call one of these points x1, one of these points y1. I'm going to call the other point x2, the other point y2. We could then plug those numbers in. I'm going to go decently fast. Sorry, I should be doing my Q's capital because they're capital in the question. y1 is 7 minus y2, which is negative 2. divided by x1, which is 4, minus x2, which is 6. If you put that in your calculator, 7 minus negative 2 is 9, divided by negative 2. That means my slope is negative 9 over 2. So if I wanted to be parallel, that's the slope I'd have to have, negative 9 over 2. Question B says to be perpendicular to PQ. Perpendicular means negative reciprocal of your slope. So my slope was negative 9 over 2. If we want to convert it to become perpendicular, we change the symbol from negative to positive, right? So if you have a negative of negative, it becomes positive. And then we flip the fraction. So this is positive 2 over 9. My slope, which would be perpendicular to PQ, would be 2 over 9. Again, remember, you could change those slopes. So instead of 2 over 9, I could change it to a decimal. Instead of, I think it's 0.222. Instead of 2 over 9, you could convert it into an equivalent fraction, multiply the top and the bottom both by 2. You'd get 4 over 18. Those are all perpendicular slopes because they all end up equaling the same thing, which is 2 over 9. Okay, last question, I think. Oh, no, 2 questions left. Class example 4. Triangle LMN has coordinates L at negative 4, 2, M at negative 2, 7, and N at 1, 0. Use slopes to show that the triangle is right angled at L. Okay, if something's right angled, that means it's perpendicular. Right? That's one of the perks of having perpendicular lines is that it creates a right angle. I'm going to sketch this quick. So they gave me coordinates. If I was to just do a quick sketch, point L was at negative 4, 2. So let's go 4 left, 2 up. Let's say it's right here, L. Point M was at negative 2, 7. So that'd be 2 to the left and then 7 up. Let's say it's up here. And point N is at 1, 0. So it'd be 1 to the right and then 0. Be right there. And they're saying that this is a triangle. So we could connect the dots to create a triangle between these lines. The question is that a right angle triangle? To tell if it's a right angle triangle, what you need to do, and just looking at the graph quickly, you can kind of tell it's like, oh, it might be a right angle right there. Might be. And it told you use slopes to show it's right angled at L. That's at L. To prove if something is a right angle or not, we need to compare the slopes. We need to compare the slope from point L to point M with the slope from point L to point N. If this is a right angle triangle, these two slopes should be perpendicular. If they're not perpendicular, then it's not a right angle. So we're going to go ahead and we're going to calculate these two things. We're going to calculate the slope of LM. We're going to use y2. Sorry, I think before I said y1 minus y2. It doesn't really matter. I'll do it again just to show you it doesn't matter. So you could say y2 minus y1. In the previous question, I did y1 minus y2. It doesn't matter which number you put first, 2 or 1. As long as if 2 comes first with the y's, 2 has to come first with the x's. You can try this on your own. If we do this, I'm going to say that, just going to erase those so it cleans it up a little bit. I'm going to say that this is x1, y1. This is x2, y2. So this would be 7 minus 2 divided by negative 2 minus negative 4. The slope from L to M is 5 over 2. Beautiful. Now we have to do the same thing. We have to do the slope from L to N. To do that, I'm no longer using point M as my y2, x2, y2. I'm now using N as x2, y2. So I'm going to go 0 minus 2. That's y2 minus y1. Divided by 1 minus negative 4. That's x2 minus x1. The slope from L to N should equal negative 2 over, and that would equal 5. Beautiful. To prove if this is a right angle triangle, we need to check and see, are these things perpendicular? That means negative reciprocals. If we look at them, the negative reciprocal of 5 over 2 would be negative 2 over 5. These are perpendicular. That means it is a right angle triangle. There we go. It is a right angle. And we proved it, right? We didn't just guess. We didn't just draw a picture and be like, oh, it kind of looks like a right angle. We proved it by doing the slopes and saying the slopes are negative reciprocals. That means they must be perpendicular. That means it's a right angle. That is a very hard, challenging question. Okay, just so you know, I'd be on the higher end of a question. All right, this one, also kind of on the higher end. This says two lines have slopes of negative 3 over 4 and 5 over, or k over 5 respectively. Find the value of k if the lines are parallel. If they're parallel, that means that k over 5 should equal negative 3 over 4. Your job is to find the value of k. To do that means to get k by itself. Looking at this equation, I have k divided by 5. To get rid of that 5, I have to do the opposite operation, which is multiply by 5. And what I do to one side, I do to the other. When you're multiplying with fractions, you only multiply the numerator. So this is negative 3 times 5 divided by 4. If you put that in your calculator, negative 3 times 5 is negative 15 divided by 4. That would be parallel to negative 3 over 4. That's the value of k that would make that fraction parallel to negative 3 over 4. If I wanted to be perpendicular, that means that k over 5 needs to equal the negative reciprocal of that fraction, negative 3 over 4. The negative reciprocal is 4 over 3, right? I changed it to become positive and I flipped the fraction. So I need k over 5 to equal 4 over 3. Again, I'm trying to find k. So that means I have to get k by itself now that I've set up my equation. To do that, I need to multiply the 5 to the other side. Again, we only do it to the numerator. This means k equals 20 over 3. That would be perpendicular. So it's the value of k that would make that perpendicular to negative 3 over 4. Wonderful. I hope you enjoyed parallel perpendicular lines. Take care of yourselves. Reach out if you need any help. Your teachers are all available. We miss you, and we hope you see you very soon.